L'Hopital's rule, this actually has to do with limits, but I can't teach it to you whenever we do limits because you don't know how to take a derivative. And you have to be able to take a derivative in order to use L'Hopital's rule to take a limit. So I always have a hard time figuring out where to put it in. And when I looked, last year I obviously put it in with this test because these questions were on the test. So we'll just go ahead and throw it in right here. It doesn't necessarily go with what we're doing right now, but we got to throw it in somewhere, and it's pretty simple. There's a lot of words here that give you conditions that you have to consider, but usually they're not a big deal. So F and G have to be differentiable functions on the open interval a to b, except for possibly at whatever value you're taking the limit at. Because normally, when we look at a limit, we're looking at one of those places where you get zeros in the denominator and it's not continuous there or differentiable. So F and G, you have to be able to take the derivative of F and G. And F over G has to give you the indeterminate form for you to use this, which is typically what we have seen as 0 over 0, but also can be like infinity over 0 or infinity times 0 and stuff like that, although we won't go into great detail on those things. We'll mostly see 0 over 0. So, if we have the limit as x approaches c of f of x over g of x, then we can take the derivative of the top and the derivative of the bottom and take the limit of that, and it still gives us the same answer. So, let's look at some problems. So, like number 1, I'm going to do both ways that you could do this problem. In the past, we would, for number 1, we would have done the limit as x approaches 4 of, we'd have 3 times x minus 4 on the top. We would factor the bottom, x minus 4, x plus 4, and we would cancel those x plus 4s. So we'd be looking at the limit as x approaches 4 of 3 over x plus 4. And then we would just plug in the 4. So we'd get 3 over 4 plus 4, or 3/8. So it's been a pretty long time since we did that. We did it some in pre-cal, and then we did it at the very beginning of this class. But basically on that one, you factor, cancel, plug in. But if you use L'Hopital's rule, then you can do this a different way. I'm not going to say it's necessarily much easier in this particular case, but we're going to see some problems where we have to use L'Hopital's rule because we can't do it any other way. So, like for example 1 here, what I could do, if I use L'Hopital's rule, I could say the limit is x approaches 4. If I take the derivative of 3 times x minus 4, which if we really think is 3x minus 12, if you want to think of it distributed, what's the derivative of 3x minus 12? Just 3. So I take the derivative of the top. And then what's the derivative of 2x? X squared minus 16. 2x. Now, when I plug in 4, I don't get 0 over 0. I get 3 over 2 times 4, which is 3/8. So, if you just use L'Hopital's rule here, then you take derivative of the top, derivative of the bottom, then a lot of times you can just plug in and get your answer. So this is really helpful if you get a problem like number 2, because number 2 is not going to factor and cancel, right? You could pull out a 3 out of the bottom, but then it's not going to factor and cancel, so you can't do number 2 the way that we did number 1. So if we have a problem like number 2, we can just say this is the limit as x approaches infinity of, take the derivative of the top, which is 2x over, not 2x, sorry, just 2. And actually, I'd take that back. We could do that one if it were approaching like square root of 3 or something. We could do this one because this is Bobo-Botno here since it's an infinite limit. But let's say that something's not clicking with us and we don't really get it. We'd have 2 over 6x, which gives us 2 over 6 times infinity 2 over infinity, 2 over an infinitely large number is just going to be 0. So on that one, I wasn't looking at the limit close enough. We could use Bobo Botno on that. Bigger on the bottom, 0, right? And still do on those, that's fine. But I'm just kind of showing you where this applies. Okay, here's our next one. So for example 3, we've got limit as x approaches 0 of the square root of 25 minus x squared minus 5 all over x. And if you plug in 0 right here, you're getting 0 over 0. And we know how to do this one a different way. We could like rationalize that numerator where we would multiply by the square root of 25 minus x squared plus 5 on top and bottom. But those can get kind of long. So the other thing we can do here is we can take the derivative. So this is like 25 minus x squared to the 1/2 power. So we would have 1/2 25 minus x squared to the negative 1/2. And then when you take the derivative times negative 2x, let's use a chain rule on that. Okay, and when you take the derivative of that 5, it's just 0, so it goes away. What do we get when we take the derivative of the bottom 1? Okay. Alright, so if we now, I'm going to simplify this up a little bit because it's kind of, technically I should still have my limit notation here. So I've got the limit as x approaches 0 of, and that 1/2 and the 2 is going to cancel each other out. So on the top I'm going to have a negative x. On the bottom I'm going to have the square root of 25 minus x squared. And so now, if we plug in, we get negative 0 over the square root of 25 minus 0 squared, which is going to give us 0 over the square root of 25, which is 5. And what is 0 over 5? 0. So we get 0 for our limit there. Okay, questions? All right, 4 is really the first one that we really cannot do any other way. Number 2, I said it was, but it really wasn't because it was as the limit as x approaches infinity. But for number 4, we cannot factor 11 minus x to the 11th minus 1 over x to the 4th minus 1. We can factor x to the 4th minus 1, but that x to the 11th minus 1 we're not going to be able to deal with. So we'll use L'Hopital's rule here. We'll have limit as x approaches 1 of 11x to the 10th over 4x to the 3rd. And now that those minus 1s are gone, you can just plug in. So you just get 11 over 4. I like it too. I really wish I could teach it with limits, but you can't teach it with limits because you don't know how to take a derivative yet. So yeah, so I just have to throw it in somewhere. And then it's very helpful if you have something like this. Now theoretically, I could think of this e to the x over x to the 3rd. Which one of these is eventually going to like take off much faster? The e to the x, right? It is an exponential. Exponentials are going to grow more quickly than x to any power, right? But let's say, so I know this it's going to be like infinity, everyone. It's bigger on top, right? So I can kind of reason through that, but let's say that we don't really remember that or it's not clicking. So if I get something like this, I could use L'Hopital's rule. So if I did this, limit as x approaches infinity, what's the derivative of e to the x? E to the x over 3x squared, which still, I'm getting infinity over infinity if I plug that in. So if I take, you can use L'Hopital's rule more than once. So I could take limit as x approaches infinity of e to the x over 6x. Still, you get infinity over infinity if you plug infinity in. But if we take the derivative one more time, you get e to the x over 6. And so now if you plug in, you get infinity divided by 6. And what is infinity divided by 6? Still infinity. Example 6, if I were to get this problem before we learned L'Hopital's rule, I really wouldn't know what to do. But with L'Hopital, because right now if you plug in 0, you've got sine of 0 over tangent of 0, and both of those are going to be 0. So if I use L'Hopital's rule, I'm going to have the limit as x approaches 0 of, what's the derivative of sine? Cosine of 5x, but don't forget to use the chain rule here, so I've got to multiply that by the derivative of 5x, which is 5, and I'm going to write that out front. And then tangent, what's the derivative of tangent? Secant squared, so secant squared of 9x, and multiply out front by 9. And then, what is cosine of 0? Cosine of 0 is 1, right? So we're not going to be getting 0 over 0 here. Secant always messes me up, so I have to think of it like this. We're going to have 5 cosine of 0 over 9 times, I'm going to make this 1 over cosine of 0 because secant is not a value that I really remember so well. So cosine of 0 is 1, so you just have 5 over 1 over 1 is still 1. So 5 over 9 is your answer. Not really. There'll be a couple on the test. Yeah, I like them. I think they're pretty easy. Okay, here's our last one that we're going to look at. So right now, if you plug in 0, you're going to get 0. So whenever we do this problem here, we're going to use L'Hopital's rule, so the limit as x approaches 0. We got to take the derivative of the top, which is a little bit tougher. We got to use a product rule for that. So we're going to have sine of x times the derivative of cosine x. What is the derivative of cosine x? Negative sine x. Plus cosine x times the derivative of sine x, which is cosine x. And what's the derivative of the x on the bottom? 1. And you can see by taking that derivative on the bottom, now you're not going to get 0 over 0 anymore. So we get the limit as x approaches 0 of, I'm going to write it like this way, cosine squared x minus sine squared x over 1. And then we'll have cosine of 0 squared minus sine of 0 squared over 1. What is cosine of 0? 1. Sine of 0, 0. So we end up with 1 over 1. So we get Otherwise, that would be a much more difficult problem to do, but whenever you use L'Hopital's rule. And L'Hopital's rule applies in a lot of cases. Like, I think there is a rule where, like, didn't we do one where, like, limit is x approaches 0, sine x over x is 1? I think we could use that, but then you have to remember all of those rules that are specific just to those formulas. Whereas if you use L'Hopital's rule here, you just get straight to the answer.